come to an example like this, it's not so easy because I cannot change 5 to base 2. So now we use the method where we log on both sides. As long as you do it on both sides, we can do it. What I do on the one side, I do on the other side. So I log both sides. And what we then do is we use that log law of bringing down the power. So x log 2 is equal to log 5. And then to have x alone, you're going to divide here by log 2, and it will cancel out. So on that side, it is then log 5 divided by log 2. And that calculation we can easily do on the calculator, log 5 divided by log 2, and the answer x is then equal to 1.22. So there we have that one's answer. So we're going to use this log method now to do exercise 18. So in the textbook now, we're looking then at exercise 18, page 67 in your textbook. Now the first one says now 5 to the power of x is equal to 2. It's just the other way around. So this one is going to be x is equal to log 2 divided by log 5. Again, you can just do it on your calculator. Log 2 divided by log 5 is equal to, and I got log 2 divided by log 5, and I got 0.457. 0.457. That's what we get there. Okay, the second one, number 2. Now it says 7 to the power of x is equal to 0.7. So this is going to be log 0.7 divided by 7, and x is equal to, again, it's very important that you will first do the exercise now before you mark further. And then it is negative 0.183 that we have there. Number 3, x to the power of 9 is equal to 7. Now, this one is different because now x is your base. X is your base. I'm going to use the same method to log both sides. So it's log x9, which is equal to log 7. Then I will still bring that 9 down. 9 log x is equal to log 7. And then I want x. I want to find x. So log x is now, and I'm going to divide by the 9. Only 9 now, the 9 value. And then in the last step, you'll have to unlock your answer. To get the answer here, we have to unlock it. Remember what we said. 2 to the power of 3 is 8. Log base 2 of 8 is 3. So this one's base is base 10. So x is then equal to 10 to the power of that log 7 divided by 9. That's how you unlock it. Or you can press second function second function log to get that value then there. And the answer is 1.24. 1.24. Question 4. A half to the power of x is equal to 3. So what will it be? Log 3 divided by log a half. And I got negative 1.58. Press your calculator. Make sure that you get the answers. Number 5, 0.3x is equal to 16 over 43. The method remains exactly the same. X is equal to log, you'll see this is a whole, you can get a value first there, or you can keep it like that, divide by log 0.3, divide by that log 0.3. And this one's answer is 0.821. Number 6, log x of 10 is equal to 4.3. Again, let's refer again back to our basic method. So what will this one be? X to the power of 4.3 is equal to 10. X to the power of 4.3. So this is where you'll have to unlock your base again. So it will be 4.3 log x is equal to log 10. So it's log 10 divided by 4.3, and then we unlock it to find x. You unlock this one then, and it is 1.71. Question 7. 4125, 1.1 to the power of x is equal to 7152. Now here we come to a very important thing which we're going to use now with our logs and our exponential graphs a lot of times. Remember, the rule here is power first, then multiply. You cannot multiply this one in. That is what you cannot do. So to be able to solve this one, in the first block, we want to get rid of this constant in front. This constant is usually your initial value. And I have to get rid of this one. So I'm going to divide there, and I'm going to divide here with 4.125. So then we have x is equal to, I log both sides, I bring down the x, and it is then log. So first we have to do this calculation here, dividing that one there, and then you divide by log 1.1. Then you divide by log 1. We have to get rid of that constant, that initial value, right at the beginning. Okay, and my answer here is 5.77. Number 8. 2 to the power of x multiplied by 3 to the power of x is equal to 33. Now, because my indices are the same, I can multiply the bases. So this is 6 to the power of x, which is 33. And then we can say x is equal to log 33 divided by log 6. Log 33 divided by log 6. And your answer there is 1.95. Question 9. 9 to the power of x is 27. Here they say you have to do it without the calculators. So now we're going to change them to the same base again. And 9 is 3 to the power of 2. And 27 is 3 to the power of 3. My bases are the same. So I just solve my indices. 2x is equal to 3, which makes x equal to 1.5. That's how we do it without a calculator. But we cannot always do it. And the last one is then log base 10 of x is equal to 4.06. So this one, again, I go back to this method. 2 to the power of 3 is 8. Log base 2 of 8 is equal to 3. So this is base 10. So x is then equal to 10 to the power of 4.06. So here you can just press your calculator, and I got 11482. 11482 then there. Okay. Now, the big new thing that we want to look at now is exponential and logarithmic functions and graphs. We want to look at those graphs specifically. So this is exponential graphs. Exponential graphs. And I think with this coronavirus, you're going to understand exponential graphs now very, very nicely, because it grows so rapidly because it is an exponential graph. So if we say now y is equal to 2 to the power of x, then this graph will look like this. We can draw these graphs with set a table, choose a scale, and you can draw the graph there. So I set up my table with my x and y values, and that is how I will plot my points. Now, 2 to the power of 0 is 1. Anything to the power of 0 is 1. So it's going to cut here at 0, 1. At 0, 1, this graph will cut. Then the next one is 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. And it grows now very, very rapidly. If I draw this graph, it's going to grow very, very rapidly there. You can see if we keep on continuing there. 4, 2 to the power of 4 is 16. It grows very rapidly. And this is now what happened with that coronavirus. We had that initial amount of people, and that's why we lock down and we stay at home, because those people get in contact with more people, and that's why it grows so rapidly every time. So when we draw these graphs, we're going to draw them like this. This is an asymptote, which means it gets closer and closer to the axis, but it will never cut the axis. You must make sure that you draw it like that with that one. The reflection of this graph in the y-axis now is this one. Y is equal to 2 to the power of negative x, which is the same as 1 over 2x. That is the same. Now, this graph will be a reflection then in the y-axis. So if the negative is there, it is a reflection in the y-axis. That's how we can draw these exponential graphs. Now, we're going to look at the textbook at a few of these graphs. There's a lot of graphs in the book already done for you. I'm not going to let us redraw all those graphs. We're going to look at them at the where they give the answers, and then we will draw a few from there. But let's first now look at them. The first one is on page 70. There you can see that graph there. And now they want you to draw exercise 19. Now, if we look at the back of the book where we have the answers, these graphs are very nicely drawn there. This is on page 170. So I want you to look on page 170. So there we have now the graph of y is equal to 3 to the power of x. And you will see it looks more or less the same as this one. It also cuts here at 0, 1. All of them are going to cut at 0, 1 because anything to the power of 0 is 1. So they will cut then there. And then you also have the reflection of y is equal to negative 3x. And there below we have y is equal to 4 to the power of x. And they all look the same. They are just a little bit steeper here, but they all look exactly the same. Okay, now they say write down the domain and the range for these graphs. So let's just look a little bit at this. And this will now be for all those graphs. What would be the domain of 2 to the power of x? If you look here at your x values, then we can say that the domain x is an element of the real numbers, because x could be any number. X could be any number. What about the range? What about the range? If we look at these graphs, we say this is an asymptote. It gets closer and closer to the axis, but it will never cut the axis. So that means that your y values is going to be more than 0. Not and equal to, but more than 0. It will be more than 0. And the last question there is, are they functions? And yes, both of them will be functions because they are a 1 to 1. They are a 1 to 1. Right. On page 71, we have the growth function and the decay functions. Obviously, if it grows, it looks like this, and if it decays, the graph will look like that. Now, on page 73, we have now this equation, y is equal to k(a)x. Now we have a constant here in the front, and this constant is your initial value. Now, again, with our exponential graphs, looking at the coronavirus, they now here, this is the constant. So, how many people had it right at the start? We don't know that precisely. Was it 2 or 3 or 4? But that is your initial value. And this is your growth factor that we have then there. So this is our initial value every time. And this is the growth factor. So if there's one person who had it, and he met 4 people, then from there the growth factor is 4. So initial value, this is your initial value, and this is your growth factor, the growth factor that it's growing with then there. So this will influence your graph now. It will change the graph a little bit. You can look there on page 74. There they showed you decay graphs, and we're coming now to exercise 20, and I would like you to look on page 171, on page 171. So there we have these graphs now there. The first one there, this is now exercise 20, and the first graph is y is equal to 5 to the power of x, and then y is equal to 5 to the power of negative x. So again, like the previous one, basically they're going to look the same. There's the reflection in the y-axis, but this constant in front just changes the shape. So that k, we said this is y is equal to k(a)x. This constant k, that initial value, changed the shape a little bit, but it still looks very, very similar to the previous ones. Look there in the textbook on page 171. You can look there at number 2. There we can see a decay graph. And number 3, there you have, look at number 3. We have those 3 graphs looking like that. The first one is y is equal to 2 to the power of x. The second one, y is equal to 3, 2 to the power of x. And the next one, y is equal to 4, 2 to the power of x. So in this graph, we can clearly see that this constant, this initial value, is changing the graph shape a little bit. But still, you can do them with your table, set a table, choose a scale. Right, then we go to page 172, exercise 21, and now we're going to look at exercise 21 on page 172. And here we're looking now at the log graph as well. So y is equal to 3 to the power of x. Again, if we draw this basic graph, it will be looking at this, cutting here at 0, 1. We must always give coordinates there. Remember, this one is asymptotes, that you draw it closer and closer to the axis. It should not lift up then there. Okay, now we need to change this one now to a log graph. So remember again, 2 to the power of 3 is 8. Log base 2 of 8 is 3. So what will this one be as a log graph? Y is equal to log base 3 of x. Can you see? So when I draw this graph now, and you can do it with your table, Now, remember now what happens with inverse graphs. The one's domain becomes the other one's range. So I can use my table. Look there on page 172. There's the table. They use the inverse functions to draw that. So this log graph is now going to look like this. So it will cut here now at 1, 0. It will cut there at 1, 0. Remember to label them. Y is equal to log base 3 of x, and this is y is equal to 3 to the power of x. And that is how that inverse graph will look like. And basically, they are all going to look the same at this one. Now, on page 172, you also have graphs with log base 3, and then the reflection of that one again that you have there. We can just look at that. So if we have now the reflection in the x-axis, remember the reflection in the y-axis will now look like this, which will be y is equal to 3 to the power of negative x. And if we draw the reflection now here of the log graph in the x-axis, then this one will look like this. Can you see? That will be the reflection then in that axis. And this one is then y is equal to negative log base 3 of x. That's then the reflection there in the x-axis. Right. Now I would like us to go back to exercise 22. Exercise 22. So this was now just the graphs here. Exercise 22. And before we start now with exercise 22, we're going to look now at E and ln x. This is what we want to look at now, E and ln x. Now, if you look on your calculator, you will see that you have those functions E and ln x on the calculator. So, for instance, e to the power of 0 is 1, because anything to the power of 0 is 1. Then we can have e to the power of 1. So press your calculator, shift ln 1, and then we get 2.718. And e to the power of 2, press your calculator, shift ln 2, and then I have 7.389. And so we can continue. So E is on the calculator as well as ln. And E and ln are now opposite operations, like times and divide and plus or minus. This is opposite operations. So the one will cancel out the other one then there. Now, we're also going to deal with their graphs. Y is equal to e to the power of x. And again, how will you draw the graph? Set a table, choose a scale. So x and y, anything to the power of 0 is 1. We said just now it's 2.7 something. 2 to the power, so you can complete a table there. When we draw this graph, it will basically look like this, exactly the same. Can you see? So y is equal to e to the power of x. And it's good to have this picture in your mind when you draw them further, that we know the basic one. This graph is also going to cut at that 0.01. Can you see? And I will also have asymptotes here. Now, the inverse of y is equal to e to the power of x is y is equal to ln x. Because we're actually going to log both sides, as we did. So to find x, we will log both sides. And log base e is ln. That is something that we need to know now. Log base e is ln. So it's just another word for the same thing. Log base e is ln. So this log graph will now look like this. Asymptotes, it will cut here at 1, 0. And remember there is always a line of reflection there right in the middle. So this is then the basic graph of exponential graphs of E and ln. Now this exercise 22 on page 82 is just an exercise to familiarize yourself with E and ln. So we're just going to look a little bit at E and ln here. Again now, you have to do the exercise first before you mark it here. So number 1a, e to the power of 3, we just get it on the calculator, and I got 20.1. The next one, look at that one, e to the power of 3, e to the power of 4, so this is e to the power of 7, because if I multiply, I add. That's where I come to that. And this gives me 116.63. So there's the 7. Number D, ln 3, press your calculator, ln 3, and I got 1.097. It's on the calculator. Number D, E3 ln 3. So you press it, E3 ln 3, and then we get 22.07. On my calculator, E and ln. Then they say, without using your calculator, just look at this one, ln E to the power of 47. Now, remember what we said, ln and E are opposite operations. So ln E is 1. That's why your answer is going to be 47. Ln E is 1. And the next one is ln E, ln E. Look at that one. So again, it's going to cancel out. Ln E is 1, ln E is 1, so the answer is 1. The answer is 1. Number 3, e to the power of 4x is equal to 7. Okay, now here we must make sure that we understand now what are we going to do here. So remember our method where we said now I log both sides. This time I'm just going to ln both sides now. Remember ln is log base E. So this is then log, or then rather ln E4x is equal to ln 7. Then I will bring down my power as we did in the beginning of the lesson. 4x ln E is equal to ln 7. But now remember what we said, ln E is 1. So we're going to say 4x is equal to ln 7. To find x now, it will be ln 7 divide by 4. Divide by ln 7, divide by 4, and I got 0.486 for that one. Number B, ln x is equal to e to the power of 3. Ln x is equal to e to the power of 3. What will this one's answer be? What will x be? The e and